Okay, so I'm going to do a problem where I break two vectors into components, and then I'm going to add or subtract the components. So we've got vector A, which is 1.5 meters long, and it's 40 degrees above the plus x direction. And B is 2.0 meters long, and it's 19.0 degrees counterclockwise of the plus y axis. I want to draw both of the vectors, find their components, and then express the vectors in component form. So you should be able to do this if it comes up on a test, or if you're given vectors in component form, you should be able to draw them. So let me start off by doing the drawing. So I'm going to draw a standard XY coordinate system. Okay, so vector A, let's draw vector A in red here. So vector A is 1.5 meters long, and it's 40 degrees above the plus x axis. So that means it's at 40 degrees above the plus x, so it's going to be in quadrant 1 here. So let me draw the vector. And let's say it's 40 degrees and 1.5 meters long. B is 2 meters long, so I'm going to have to make it a little bit longer when I draw it. And it's 19 degrees counterclockwise. Let me draw it in blue. Counterclockwise of the plus y-axis. So the plus y-axis is this vertical axis here. So it's going to be 19 degrees counterclockwise. So clockwise is around towards the plus x. Counterclockwise is towards the minus x direction. And 19 degrees, so I'm going to do something approximately like that. So there's my vector B in blue, and vector A is in red. All right, so what are their components? Well, if I draw a right angle triangle, so I take a line and I drop it perpendicular to the closest axis. All right, so BX is the side that's parallel to the x direction. AX is the component of A that's parallel to the x direction. And BY is the side of that right angle triangle that's along the y direction. And AY is the side of the red vector that's parallel to the y direction. So the vertical side is y and the horizontal side is x. So now what I need to do is I need to look at these triangles and figure out what's the x component and what's the y component. So I'll write my vectors. So let's switch back to red to do x. So AX and AY. So AX and AY are going to be either A sine theta or A cos theta with a plus sign or a minus sign. So we need to look at what quadrant we're in and figure out whether it's a positive number or a negative number. So let's look at vector A. Vector A is in the first quadrant. It's got a positive value for x because it's going over to the right, and a positive value for y because it's going up. So I know those are going to be positive numbers. So I can go ahead and put a plus sign in front of them. Okay, and now I need to figure out whether they're sine or cosine of 40. So if I look at the x side is the horizontal side. And you can see that side there is touching the 40-degree angle. That means it's adjacent. And if it's adjacent, I use cosine. So it's going to be a cosine of 40. And so I'm going to put in A is 1.5 cosine of 40. Throw that in your calculator. Make sure your calculator is in degrees, not radians. And if it is, you get 1.149 meters. Now, it's not the right number of significant figures, but I never round off until I get to my final answer. So I'm going to leave it with lots of significant figures right now. All right, so if x is cosine, then y's got to be sine. But let's take a look at it. This side, AY side, that's opposite to the angle. Okay, so if it's opposite, that's going to be sine of 40. So AY is 1.5 sine of 40. And that's going to be a smaller number, 0.964. 0.94 meters. Okay, so I've drawn both my vectors. I found the components of x. Let's find the components of y. So let me switch to my blue color. All right, so for b, bx, and by, we're going to do the same thing. It's going to be b, the magnitude of b, which is going to be 2, times either sine or cosine. We've got to look at the picture and remember the angle is that small angle in there is 19 degrees, if I can squeeze that in there. All right, so now let's look at my x component and my y component. So my x component is up here at the top, and that is opposite to my angle. So bx is going to be sine of 19, and by, that side is touching the angle, so it's adjacent, so that's going to be cosine of 19. Now, are they positive or negative? So I'm in quadrant 2, and if you look, the y side, that's going up, so that's going to be positive. The x side, that x direction is going backwards towards the left, so that's going to be negative. So I'm going to have a negative x component and a positive y component. So I'm going to have minus 2 sine of 19 for the x, so it's going to be minus 0.651 meters. And for by, it's going to be plus 2 cosine of 19, and that's 1.891 meters. If you're doing a test, you're not sure if your calculator's in the right units, always just do the sine of 30. Sine of 30 degrees is 0.5. So if you don't get 0.5, then you know you must be in radians. You need to change the units. All right, so I've got the components. So now I just need to express each vector in component form. So that means I got to use those I hat and j hat. So vector A is equal to 1.149 in the x direction, so that's I hat, plus 0.964 in the y direction, so that's j hat, and then usually I would put a unit of meters after it. And b is minus 0.651 I hat plus 1.891 in the y direction, j hat, meters. And again, I should probably have technically rounded these numbers off to be 2 significant figures in my final answer, because a and b have 2 significant figures. So it should be 1.1 plus 0.96 and negative 0.65 I hat plus 1.9 j hat for b. Okay, so we're done the first part. Now let's do something where we take these 2 vectors and we either add or subtract them. So let's do a subtraction just to be different, because in the online video I did an addition. So I'm going to take vector c. Let me move that up there so I got a little bit more room. So c is going to be b minus a. So I want to find the components of vector c, draw it, and find its magnitude and direction. All right, so how do I do it? Well, if I'm subtracting, cx is going to be bx minus ax, and cy is going to be by minus ay. If I were adding, if c were b plus a, I would just add those components. All right, so now all I have to do is look at my 2 vectors there at the top of the screen and plug in the numbers. So bx is negative 0.651, and ax is 1.149. I'm going to subtract it, so negative 1.149. So cx is going to be negative 1.80 meters. And cy is going to be by 1.891 minus ay minus 0.964, and I get plus 0.927 meters. So if I were to write vector c in component form, C is equal to negative 1.80 I hat plus 0.927 j hat, and the units meters. Okay, so I found the components. Now I need to draw it. So let's put on our x and y axis again. All right, so now I need to go backwards, minus 1.8 in the x direction. That's my instructions over here. So it says go minus 1.8 in the x direction, and then go plus 0.927 in the y direction. So let me make sort of distances that are equal. So I'm going to go back almost 2 in the x direction, something like this, and then I'm going to go up almost 1 in the y direction. Okay, so those are my components, and so my total vector C, I'm going to draw from the origin to the end of CY. So there's my vector C, is the hypotenuse of that triangle. Okay, so now last thing is find the magnitude and the direction. So when you find the magnitude, you always use Pythagoras' theorem. So Pythagoras' theorem says that the magnitude of C is equal to the square root of cx squared plus cy squared. Okay, so that's going to be square root of negative 1.80 squared plus 0.927 squared. And you need to be careful. Some of you, your calculators with the brand, I don't know what it is, but if you square a negative number, you know you should get a positive number. Double check with yours, because sometimes when you square it, it does not come out as being positive. So if you're not sure, just always drop the negative sign if you're squaring it, and your answer should come out right. So if I do that, I get my C is 2.025 meters, and I should round that magnitude off to 2 significant figures, so 2.0 meters. All right, to get the direction, how do I get the direction? Well, I use tan theta is cy over cx. So cy is 0.927. Cx is negative 1.80. And so I get tan of theta is negative 0.515. And there's no units for that because I'm doing meters over meters. It cancels out. So how do I get my angle? Well, I have to do the inverse tan. Right? So I'm going to do tan to the minus 1 of negative 0.515. Okay, so that's equal to theta. And if I put that in my calculator, it gives me an angle of negative 27.2 degrees. So if I just gave that answer, that would be wrong. So what I have to do is I have to go back and I have to look at my picture. So that's why it's always important to draw a picture of your final vector. And let me go back. I'll go to red so we can see what I'm drawing on here. Where is there an angle that looks like it's about 27 degrees? Well, it's sure not that angle, is it? That angle is way bigger than 90 degrees, and it's not that angle. That angle is bigger than 180 degrees. So where is an angle that looks like about 27 degrees? It's that angle in there between the minus x direction and vector c. Okay, so that angle is my 27.2 degrees. So when you're telling me what the angle is, you need to tell me with respect to what. So I could say that it's 27.2 degrees, or I should round that to 2 significant figures, 27 degrees above the minus x-axis. Or if you're putting your answer in on the homework service, then you need to put, they want to know the angle from the plus x direction. So they want to know this bigger angle from the plus x direction over towards your vector. So that's going to be 180 minus 27.2, which would be 152.8. And I guess in two significant figures, that would be 150 degrees from the plus x direction. What would we do if it were down in one of the bottom quadrants? Well, if it were down in quadrant 3, which is this one over here, or in quadrant 4, then for the mastering homework, you would give a negative angle from the positive x direction. Right, so if it were in quadrant 4, it would be a number between 0 and negative 90. And if it were in quadrant 3, it would be somewhere between minus 90 and minus 180. Okay, so if it's in quadrant 1 or 2, you can give a positive number on the mastering homework. And if it's 3 or 4, you'll give a negative number. Okay, so that's a quick run through. And your exercise for today will be to do an addition problem of two vectors very similarly. In the module for this quest, you'll find a uploaded PDF scan of the solution if you need to have it a little bit neater.